Hello class, and welcome to lesson 6.5 applications day 2. Want to give you a heads up folks that there's going to be a quiz coming up in class, so I want to make sure that you have been doing your homework and that you've been seeking extra help if you need to. We're just after today going to be doing quiz and then review for an upcoming unit test, so please make sure you've checked the website or talked to your teacher about when the actual test date is. So let's start off with the warm-ups here folks. It says, given this equation, remember that's in vertex form, which is y equals a bracket x minus p squared plus q. Okay, we need to do a bunch of things, a bunch of questions. First one says to state the vertex. So for A, ladies and gentlemen, just remember your vertex is p and q. So what does that mean? In this case, the vertex equals 2 and negative 4. All right. Question B. Okay. If you were to graph this function, what would be the y-intercept? And it says solve using 2 different methods. Well, the easiest method to solve is method 1. And method 1, folks, is when to find the y-intercept, you're going to let x equal 0. So I'm going to rewrite this equation wherever I see an x, I'm going to put a 0. So it's going to be y equals 3 times 0, sub that in, minus 2 squared minus 4. Do some calculations here, folks. In your math or mental math, or get your calculators out. 0 subtract 2 is negative 2. You square it. It's going to be 4. So 3 times 4 is 12 minus 4. And plug it in your calculator, or just use your mental math. Y equals 8. That's one method. Method 2, for part B, because it says to show 2 different ways. Method 2 is switching to standard form. And once we find standard form, we have to look for the y-intercept, which is the what? C value. So we're going to switch to standard form and then look for the C value. So if you forget the steps, you got to just kind of follow BEDMAS. So I'm just going to write the question out again, so I've got it here. Okay. Now step 1, ladies and gentlemen, is to deal with the exponents. So you've got to square the binomial. So you leave a out front. Okay. To square the binomial, square the first. So x times x is x squared. Double the product. So 2 times x times negative 2 is negative 4x. And then you square the last, which is negative 2 times negative 2, which is positive 4. So that's called squaring the binomial. And don't forget you still have the constant of negative 4 at the end. Step 2, ladies and gentlemen, is to perform distributive property. So you're going to multiply a into everything inside the brackets. So y equals 3x squared minus 12x plus 12. But don't forget we still have our other constant here, which is negative 4, or subtract 4. And our last step, folks, is to collect like terms. So y equals 3x squared minus 12x, and we're going to have plus 8. Remember, folks, that once you've got your standard form, you're going to check and say C equals 8, therefore y equals 8. Or y-intercept. How do we fix that to y-intercept? Equals 8. So, folks, on your test, this is one you can do a check for the other on this, all right? Okay, C says to state 2 symmetry points. Well, I would say that probably the easiest one to do symmetry points is to do partial factoring, but you could also do fully factoring. But in this case, looking at the equation, it doesn't look like it's going to be easy to factor. So I'm going to do for question C, I'm going to do partial factoring. Okay. And this is just going to be method 1. I'm going to show you another way, if you're a visual person, on another way of coming up with 2 symmetry points. Just remember, folks, that when you have any quadratic, if it opens up or down, okay, I'm just going to quickly draw one here. There is an infinite number of symmetry points. The only spot on your quadratic where you do not have a matching symmetry point is at the vertex. But anywhere along here, so if I have a symmetry point maybe 1 to the left, I'm going to have one 1 to the right. If I go 7 to the left, I'm going to have 7 to the right. And because the function continues on and on, as you go up, it goes out. That's why there's an infinite number. Okay? So just a quick review on partial factoring, folks. What we're going to do, folks, is take a look at the parabola. What do we know about it? Okay, so first of all, it's in standard form. So we know from our standard form that it's at y equals 8. Okay, we know our vertex is 2 and negative 4, so it comes down and goes back up. Okay, so these are just things that we've already figured out from the question. So we know this is 8. We know our vertex is at what we've already said, which was 2 and negative 4. Okay, to partial factor, folks, we're going to remember the method. We let y equals c. So in this case, we're going to let y equal our c value, which is 8. So what does that mean, guys? I'm going to put our line across here, and I'm going to find one symmetry point, which should have a value of x being 0. And the other one is going to be out here. So we're finding 2 points of symmetry. Okay? So on our equation, if we're going to let y equals 8, instead of writing y, we're going to go 8 equals the rest of the equation. Yeah, you have to use the standard form, ladies and gentlemen. You can't use the factored form. Okay, so you had to answer that one first. Okay, what to remember happens to our 8s, folks? They cancel out, so you've got 0 equals 3x squared minus 12x. Now, partial factor means you got to partially factor these out. So what can we common factor out of the remaining 2 terms? And that's going to be a 3 and an x. So what are we left with? We're left with x minus 4. So what does this give us, folks? The first symmetry point that we're going to get is x equals 0. And the second one is going to be x equals 4. So just to back up here, folks, this is going to be 0 and 8. And this is going to be 4 and 8. So you're going to say, therefore, sim points are 0 and 8, because remember, you let y equal 8 to begin with, right? And your second one is going to be 4 and 8. All right, that's one way to take a look at it. The second method, folks, is method 2, which I'll do over here. We haven't taken a look at this, but this might be something if you're a visual person. You might just want to go one left and one right of the vertex. So this one's called step pattern and vertex. Okay, so what do we know? We know the vertex, folks, is 2 and negative 4. And whenever we go to graph that, folks, we always want to go step pattern to the left and then step pattern to the right based on the vertex. So if we were going to go 1 to the left, folks, that would be x equals 1. If we were going to go 1 to the right, that would be x equals 3, looking at the x value, right? Okay, so what we need to do is apply the step pattern to it. Okay, so what I want you to do is realize that our step pattern is normally 1, 3, 5, but what is a in this case, folks? A is 3, so step is going to be 3 times 9 times 12. Okay, I apologize, 15. Let me fix that up. It's 1, 3, 5. My fault, not 1, 3, 4. Okay, so what does that tell us? If I move over 1 to x minus 1, I got to take my negative 4 and I got to go up 3. So negative 4 plus 3 equals negative 1. Okay, so that's what my y value would be. Okay, likewise, if I'm at x equals 3, I have to take negative 4. Okay, and I have to go up 1. Sorry, I have to go up 3. That's my step pattern, folks. Okay, and that's going to also equal negative 1. So y equals negative 1. So in fact, folks, instead of, if I use this graph here, instead of finding the partial factoring ones we did here, I'm just going to go to the left one and find this symmetry point, go to the right one and find the symmetry point. They're going to be the same. So here's another example of another answer for sim points. So sim points here, by using the vertex and the step pattern, are going to be 1 and negative 1 and 3 and negative 1. Okay? So if you're a visual person, you might like that. Okay, last question in our warm-up, folks, said state the zeros of the function. So when you want to do the zeros, you need to solve. Okay, so the zeros of the function occur when what? Let y equal 0. Okay, and we're going to make sure we either get it into factored form or refactor or use quad formula. Okay, so we are at, okay, so based on our graph, folks, we're looking, if I can just quickly hiccup on this second graph here, we're looking for these here, okay, the ones that are in red. Okay, so taking a look, ladies and gentlemen, we have standard form. I'm just going to write it out again. Okay, so we've got y equals 3x squared minus 12x plus 8. Okay, if we quickly want to do this, ladies and gentlemen, let's take a look. Product equals a times c, which is 3 times 8, which equals 24, and sum equals negative 12. Ooh, what two numbers multiply to 24 and sum to negative 12? Well, guess what? There isn't any, so we can't factor, therefore we're going to use quad formula. Okay, so again, you spend 1 to 2 minutes trying to figure out if you can factor because it's easier. If not, you're going to use quad formula. For those who forget, I'll tell you what A, B, and C is. So A equals 3, B equals negative 12, and C equals 8. Okay, so plug it in the formula. So x equals a negative times a negative becomes a positive 12 here, folks. Plus or minus the square root of negative 12 squared. Make sure that's in brackets, guys. Minus 4 times a, which is 3, times c, which is 8. All divided by 2 times a. Okay. Let's simplify this through here. So we're going to have 12 plus or minus. Simplify your bracket, ladies and gentlemen. You should have 48. Okay. To simplify the denominator should be 6. Break it into its two cases. Okay, so we've got x equals 12 plus root 48, all divided by 6. Okay, plug that in and you will get 3.15. Okay, try the next one, or the other option, which is x equals 12 minus root 48 divided by 6, and x equals 0.85. Okay, so when it says to find the zeros, you're going to say, therefore, the zeros are 0.85 and 3.15. I usually go in numerical order, guys, when I table them. All right, there's the warm-ups. I'm going to pause for a second while you write down the examples. Now, ladies and gentlemen, I know these examples are long, but there's no written note to your lesson today. So you just need to write the examples down, and then we are going to do the lesson, okay? Or I'll go over the answers with you. I'm just going to pause. All right, class, let's take a look at example 1 here. This is a business model, so if you plan to open your own business or be in the business sector or marketing sector, this is going to be important to you. So let's read this example. When manufacturing a certain product, the cost per item becomes cheaper the more items that are made. However, at a certain point, the cost begins to increase due to overtime expenses. The cost per item, C in dollars, can be represented by the equation, which is given right here, where X is the number of items produced. Okay, as always, one of my keys, folks, when you're dealing with word problems is tell me, what form of the quadratic is this in? So we know this is in standard form. Okay, and what does standard form tell us, ladies and gentlemen? It tells us the y-intercept. So y-intercept, in this case, is the C value, which equals 1,200. What does that mean, folks? If you're starting a business, the setup cost or the initial cost to get started is $1,200. That's a cost, okay? Not a profit, that's a cost, okay? So we already know that's in standard form. We already know the y-intercept, okay? So let's take a look at question A. Question A says determine the number of items that should be produced to minimize the cost per item. So where does minimum and maximum occur, guys? The minimum occurs where? At the vertex. Oopsie, let me spell that right. Occurs at the vertex. So what do we need, guys? We need vertex forms. So what do we need to do? Therefore, we need to complete the square. Make sure by now you should know that whenever you ask for the vertex and it's in standard form, you need to complete the square. That needs to be automatic for you for your upcoming test, okay? All right, so I'm just going to rewrite the equation. C equals 0.1 x squared minus 20x plus 1200. I'm going to move this up. Okay, let's just quickly go over the steps for completing the square. We want to get a out of the first two terms. So a is 0.1. Be careful here, you might need a calculator, guys. What is negative 20 divided by 0.1? You're going to get negative 200. Just remember, guys, the number's getting bigger because you're dividing by a decimal. That's why. And we leave the 1200 out at the end. Okay, so far, looking in our brackets, folks, we need to get that perfect binomial. So we've got two terms. We need to find that third term. So we're going to do our margin work. So b divided by 2 equals negative 200 divided by 2. That equals negative 100. And again, you got to do your second step, which is b divided by 2, and you square it. So that's going to be negative 100, and you square it. That number is going to be 10,000. That's the number you're going to add first and then subtract. Okay? So let's do that. So you write everything else out the same. You add 10,000. Don't forget to also subtract 10,000. Okay, and then please let me just erase this and put down, we don't want to forget our constant term here, which is plus 1200 still in here, okay? Sorry, I ran out of room there. All right, so we're halfway there, guys. We know that our a is out front, 0.1. The first three terms are our perfect square. So take the square root of the first, the sine of the second, the square root of the last, and square it. Or, guys, take the square root of the first, and you know your p-value is right there already. Okay? And don't forget, when we go to take a look here, this negative 10,000, it needs to come out, but make sure you times it by 0.1, and now it's going to be subtract 1,000 when you times it by 0.1. So don't forget to times it by a when you bring it out. And we still have our constant of plus 1,200 here. Last step, ladies and gentlemen, is to collect like terms in our constant term. So we've got c equals 0.1, x minus 100 squared plus 200. Okay, so what does this mean, folks? Let's take a look at our vertex. Our vertex is 100 and 200. Okay, and we got to go back to what the question asked. The question says, determine the number of items that should be produced to minimize the cost. So take a look, folks. The minimum cost per item is the 200, and when does it occur? When we sell 100 items. So let's put that into a therefore statement. So therefore, the minimum cost per item occurs when it is $200, and that's at selling 100 items. All right, so there's question A done. Question B says to make a profit, the cost per item must be less than 400. Okay, how many items would be produced to accomplish this? Okay, so what we can do here, folks, is we can do a little bit of a visual to start off with. So before we take a look, let's take a look. We know that X, which is our number of items, and C is our cost. We know that our initial y-intercept is 1200 here, folks. We know that it comes down to our vertex, which we've just calculated. So our parabola, it opens up because it is positive. I mean, A is positive. Okay, so what do we know? We know that this is 1200. That's our initial startup cost. We know our vertex, which occurs at the minimum in this case, folks, and our vertex here is 100 and 200. Okay. Now the question says, determine the number of the cost per item must be less than 400. Okay. So again, we're going to take a look and throw in a line here at 400. So we're going to let cost equal 400. Okay. And we're going to find these two intersection points, which are here and here. And we got to be careful that we need to have less than. Okay. So we have to have less than our point of intersection. Okay. So less than the P of i's. Sorry, I'm having trouble writing here. Less than the P of i's. Okay, so that means we have to solve. So we're gonna, wherever we see our equation, we're gonna sub C for 400. So it's gonna be 400 equals 0.1 x squared minus 20x plus 1200. Okay, before we can solve, we need to move the 400 to the other side and collect it. So it's going to be 0 equals 0.1 x squared minus 20x. Let's collect like terms here. It's going to be plus 800. Okay, now we can try to do a fully factoring here, guys, but I have a decimal right away, so therefore I'm going to use the quad formula. Okay, so we're going to sub it in. So x equals, subtracting a negative b is going to become positive 20. Okay, plus or minus negative 20 squared minus 4 times a, which is 0.1, times c, which is 800, all divided by 2 times a, which is 0.1. Okay, let's plug in our calculator and simplify this a bit. So x equals 20 plus or minus, simplify your square root and you should get 80. Okay, all divided by 0.2. Okay, just going to make my fraction line a bit smaller. Then we can break it into its two cases, folks. So we've got x equals 20 plus root 80, all divided by 0.2. Okay, and the second case, folks, is going to be x equals 20 minus root 80, all divided by 0.2. I just got to fix my line there, folks, because it went over there a bit. I'm going to fix that up. So it's x equals there. Okay. Now plug these in your calculator, folks. Okay. So when you plug the first root in here, you're going to get 144.72. Okay. And the other answer, when you plug it in, is going to be 55.28. Okay. So I want to go back to our graph for a second. Okay. So the first point of intersection, guys, it makes sense. It's got to be the 52.58. 52.58 is right at the point of intersection. So if we want to be less than, we have to go to the next whole number after it. So that would be 56. So to be below or under, we need to have 56 items as our lower limit. And then for our upper limit, ladies and gentlemen, right here at the second point of intersection, which is right here in the green, that's 144.72. So we need to be just below that. So the next whole item that's below it for our upper limit in terms of what we can fit in here, guys. This is our limit down in here, okay? And it's going to be 144. Because if you did 145, folks, you'd be up here, which I will erase now because that's inappropriate because it's above, right? So then you're going to say in the therefore statement, okay, so therefore between 56 and 144 items, comma, the cost will be below $400 per item. Okay? Awesome. Last question, folks, C. C says, what is the startup cost to manufacture these items? Well, we should know that the C value in standard form is your startup value. That's what we're looking at here. Okay? Which in this case we've already identified, so we're going to say therefore startup costs are $1,200. Don't forget your units there. Awesome. Okay, so folks, that's a business model. Now we're going to take a look at a completely different example. Example 2, if you're a lifeguard, you might have some experience with this. Okay, so example 2, a lifeguard marks a rectangular swimming area at a beach with a 100-meter rope. The width of the swimming area is X meters. The area of the area in square meters is expressed by the expression there. You can tell it's quadratic and it's in standard form. It says to draw a diagram. So the first thing we want to do for A is draw a diagram. So at some point we're going to have the shore here. Okay, and hopefully if you've been to a beach, folks, you know that when you lay a rope out, it's only 3 sides. So there's one width, a length, and then one more width. Okay, so this is the water part here. Okay, the blue part's my rope. Okay, so taking a look, ladies and gentlemen, it says in the question that we need to express the width is X meters. So we're going to label our width being X, and we have 2 of them. Now we want to find our length. However, we don't want to express another variable. We want to express length in terms of X. So what we need to do is to use some important information which is called the perimeter. And that's the value of the rope. So the rope is the measurement of the 3 sides. So that equals 100 meters. Okay. Now if we think about it, logic tells us the perimeter, folks, has 2 widths plus 1 length in our case. Okay, 2 widths plus length, that's L for length. Okay, we know that our perimeter is 100. And we know that the width has to be represented by X because that's what the question asked us to do right here. Okay. And so what we're going to do is we're going to rearrange this equation that we've been working in green in terms of L. So I'm going to take the 2x, bring it over, and change its sign. So it's going to be 100 minus 2x equals L. So folks, that's the measurement I'm going to put right here in terms to represent the length. Okay, notice now, folks, I've got all variables in terms of X. And you're going to say, Miss R, why do we put everything in terms of X? Because that's how the expression is shown here. Okay, it just has X variables. You don't see any W's, you don't see any L's. So that's why we needed to do that. Okay, so B might give you even some more understanding of this. Okay, so B says explain how this equation was created. Okay. Well, we know that in general, area of a rectangular area is length times width. Okay, if we sub in the length and the width from our formula, the length is, oopsie, hold on, my computer's doing something funny. Okay, there we go. So we know the length is 100 minus 2w, and we know that our width, sorry, 2x, my fault. Let me switch that up. Okay. And we know that our width is to be expressed by X because that's what the question told us. And if we do distributive property, guys, A equals 100x minus 2x squared. If we put it into standard form, A equals negative 2x squared plus 100x. Okay, so that's your proof, and that is what's given, right? So that was the equation that was given. Okay, another way to find length, folks, is length equals the area divided by the width. Okay, so length equals, what was our area given? Negative 2x squared plus 100x, and you got to divide it by your width, which is x. So if you factor this through, folks, you're going to get the length equals, in this case, negative 2x plus 100. Because you just divide both terms by x, or common factor out an x. Okay? So that's another way you could come up with that. Okay? That is exactly the same as 100 minus 2x, which we have right here. Okay, so we've got A, B done. Let's take a look at question C. Question C says, what is the greatest area enclosed? Another word for greatest is, folks, maximum. So we want to find the max area. Okay, where does maximum or minimum occur, folks? At the vertex. Okay, and how do we get the vertex? We need to complete the square. That should be ingrained in your brain for your upcoming test. And keep it in there for your final exam too, guys. All right, so what do we know? We know that we have our expression. I'm just going to rewrite it. Area equals negative 2x squared plus 100x. Okay, and our first step to completing the square is to factor out a to the first two terms. Good news here is, guys, we don't have a constant, so it's just the both terms. So you take the negative 2 out, so you're going to have x squared, be careful with your sign here, minus 50x. Okay? To find the third term that goes in our bracket, we have to do some work on the side. So b divided by 2 equals negative 50 divided by 2, which equals negative 25. We then need to square that, ladies and gentlemen. So it's negative 25 in brackets squared, and that's going to equal 625. That's the number we're going to add and subtract right in here in the next line. Okay, so let's do that. So area equals negative 2 x squared minus 50x plus 625 and minus 625. Okay, we're getting there, folks. Hang on. Area equals negative 2. We take the first three terms and complete the square, or make it a binomial squared, I should say. So square root of the first is x, sine of the middle, and square root of the last, if you're not sure. That's right there. Okay, and don't forget, ladies and gentlemen, for our last term, the negative 625, you got to times it by negative 2, so that's going to give you plus 1250. So our vertex here, guys, is 25 and 1250. Okay, and the question says, what's the maximum area? And the maximum area is right there. So therefore, max area of 1250, don't forget your units here, meters squared. Okay, and when does it occur, folks? It occurs when x is 25, and that's the width. But I'm not going to answer that right now because that's the last question here, D. So D says, what dimensions maximize the area? Well, we know that x equals 25, therefore our width equals 25 meters. Okay, and to find L, we sub it into the equation we had up top. L equals 100 minus 2x. We sub in our x value, or the width value in this case. Okay, so we're going to have 100 subtract 50 here, guys. So the length equals 50. Okay, so therefore, length is 50 meters and width is 25 meters. That's the dimensions. All right. Ladies and gentlemen, we are done. Okay. All right. Give me 1 second, please. Okay, guys, I forgot. The next page has your homework. I was wondering where it was. There it is. So, homework is page 322, numbers 6 to 10. That's 4 questions. Give it a go, folks, and please really take a sincere effort to get this work done. See me for extra help. Let's get in high gear because this unit test is coming up, and I want everybody to be really successful. And as always, come see me if you need any extra help. Have a great day, guys.